let's get started. So our seminar will be very short because we will discuss only several problems. And first of all, I want to finish their problem. So we did not consider the unstable position, this upper position of the pendulum, which is unstable. How to prove that it is unstable using the Lyapunov's instability theorem? Let's do it. Let's construct the corresponding function for this situation. Well, let's do this. Okay, so we consider undamped pendulum, and we want to prove that this upper position is unstable. Now let's do this. Okay. First of all, we can note that our upper position has the coordinates p0, pi0, yes, and it is not the origin. It is not the origin, and so we should introduce new coordinates. So it is x, y. We must make a change of variables. Let x be equal to u plus pi, and u will be the new variable, and y equal v, or u is equal to x minus pi, v equals y. Then this equilibrium position will move to the origin in terms of coordinates u and v. Is it clear? So we make a translation of coordinate system to move our critical point to the origin. Next, we need to rewrite our system in terms of u and v, in terms of new coordinates. Well, so x dot is equal to u dot. So u dot is equal to v, because y is v. Then y dot goes to v dot, which is equal to minus g over L sine x. But what is sine x? It is sine of what? U plus pi. Change of variables. And then how to find u dot? It is the same as x dot.
Yeah.
Because they differ by constant.
And why is x dot equal to v?
Because x dot is equal to y, then u dot is equal to v. Because v and u are the same, and x is equal to u plus pi.
So we're using that formula.
Then, yes, these formulas, yes. And I rewrite this system in terms of new variables u and v. Because I want to apply machinery which is used for the origin only. Yes. We must make a translation of the coordinates. Yes. So what is sine of u plus pi? In terms of can we simplify this? Minus sine, yes. So we have the following: u dot equals v, and v dot equals g over L sine u. So this is the new system.
But why is minus sine u?
By trigonometric formulas. So how is it? So sine u plus pi equals minus sine u. From school. Ну да, 180. Да, поворачивается все. Well, and now I suggest the function u and v. It will be equal to v times sine u. Let's try this function. Okay, is it positive definite or negative definite or semi-definite? What about this function? Follow your question.
You chose pi. Pi can be anything, right? So is there a reason you chose pi as the
The reason to introduce pi, to choose, to
Yeah, why did you choose pi? Why not maybe some arbitrary number?
pi because because this is the critical point for which theta is pi. Yes, so it is the vertical position, vertical equilibrium. It is I want to prove that it is unstable. So first of all, I should move this. It is related to so theta. Theta is pi at this position and y is 0. So I first of all I must move. I must translate the axis. Okay, but this position can be found. These two positions can be found from just this system. Yes. So to find the critical point, we must equate right-hand part to 0. So y must be equal to 0 at the critical point. Yes, y, and sine x must be equal to 0. Sine x is 0 for x of the form pi n, where n is integer. Yes, so when n is 0, then we have this low equilibrium point, and it is stable, and it is studied. It is already studied. Yes. Now we want to consider the case when n is equal to 1. So it is periodic, and so we need not consider 2 pi, 3 pi, and so on. So it's enough to consider only two cases, when n is odd and even. Yes. So n is 0 and n is 1. Now for n is 1, we must translate the origin to so this point to their origin. Yes. Okay. So let's try this function. So I took it from the book, and let's discuss it. Is it positive definite or negative definite or semi-definite or what? Or indefinite? What can we tell about this function? For different u and v near 0, u and v are both near 0. So v of 0, 0 is 0. Is it positive, negative, definite or negative definite? Neither. because in the neighborhood of 0 of the origin, it may take positive and negative values. Yes. So if u and v near the 0, so if we take the point near 0 from the first quadrant, then both are positive. If we take point from here, then v is positive and sine is negative. Sine is also positive, positive and positive, yes. And here, so sine u is negative. Yes, yes, it is negative. V is positive, sine is negative, so negative. Positive, negative, then both negative. Positive, negative. Yes.
Another question: the VUV is given to us, right? VUV equals to V multiplied by sine u is given.
Yes, yes, yes. It is given, and we check that using this function we can solve. We can prove that our equilibrium is unstable. Yes. So this function. So does it satisfy the hypothesis of the second theorem, instability theorem, Lyapunov instability theorem? So. Yes, yes. So it mustn't. It need not be positive definite or negative definite. Yes, there must be a point at which it is positive. Yes, and it is 0 at 0. Yes. So the first part, the first hypothesis is satisfied. So let's check the second hypothesis. Next, we must find v dot with respect to, so the derivative with respect to the system. Yes. So take the partial derivative with respect to v. It will be sine u and multiplied by v dot, which will be taken from here. Yes. And plus v cos u times u dot. And let's substitute this point. So sine u is, yes, sine u is sine u. Then v dot is this, minus g over L sine, so it's not minus, it is taken from this system, of course. Sine multiplied by this sine u. And plus v cos u and v. And we will get the following, g over L sine squared u plus cos u times v squared. Okay, what about this function? Is it positive definite or negative definite or neither? Near the point, near the origin. Near the u cos u near the origin, it is positive. It is positive. It is near 1. Yes. When u is 1, then cos so so cos 0 is 1. Cos 0 is 1. So if u is near 0, then cos u is near 1, so it is positive. Positive. Multiplied by v squared. Yes, it is positive definite. It can be 0 near the origin, and it can't be negative. And it is 0, so if we substitute 0 for u and 0 for v, we will get 0. So it is positive definite. Positive definite. And then we can apply the instability, Lyapunov's instability theorem with this function. Вот тут, so is here. V capital using the same formula as was written there. So partial derivative. So first partial derivative. So we consider this function. Yes. First of all, we take partial derivative with respect to v and multiply by v dot. Then partial derivative with respect to u and multiply by u dot. And then substitute these two functions for v dot and u dot. Okay, and analyze the answer. Yes. So it is, of course, difficult to guess this function, and so this is some you should try to find it. Okay, so now let's try to solve some tasks. After this, we will finish. So the tasks can be solved using one and the same function, which is equal to x squared plus y squared. Okay, so we will try the function v of xy, which is equal to x squared plus y squared, to check stability and instability of the following system. So the first system is the following: x dot is equal to minus x y squared, and y dot is equal to minus y minus x squared y. Okay, welcome.
What is the equation though?
So this is the system. This is the function. Try to use this function to check stability and or instability of this system.
What is the domain?
Domain near the origin. So R, of course, R2, but it is locally. It must be locally stable or locally unstable. So near 0.
Always greater than or equal to 0, so
So positive semi-definite.
So it is positive definite, of course, because it is 0 only at the origin. At other points, it is positive. So positive definite, not semi-definite. But I think you may use greater or equal, but it is 0 only at the origin. Yes. Mm-hmm.
Okay, now we do. V dot is equal to
Mm-hmm. Mm-hmm.
substitute for y
Mm-hmm.
plus 2y and y dot is minus minus
Mm-hmm. Mm-hmm. Okay.
here and 1 plus x.
Mm-hmm.
Now this term is always positive or
Yes,
positive,
yes, uh-huh.
and then the positive 0, so the
Mhm.
whole thing
So sometimes y may be 0, yes? If y is 0, then x is not 0. So if we are near the origin, and for any point except for the origin, x is not 0 or y is not 0. If x is 0, then y is not 0. If y is 0, then x is not 0. So it is negative but definite, of course. Negative definite, and so this proves that it is negative definite. And if this is positive definite and it is negative definite, then asymptotically stable. Yes, asymptotically stable. Like in physical problem, like in the problem of pendulum. So this is the idea how to memorize this. Yes. So if we have if we approach the origin, so v dot must be so v must increase, so v must decrease, right, when going to the origin. So if the if trajectory approach the origin, then v must, so it is positive definite here, yes, and it must increase when going to the origin. And so this must be negative because it is decreasing along the trajectory. Yes, so this is the idea how to memorize.
And what is the case when we don't know if it is asymptotically?
It may be just stable but not asymptotically stable, like in the motion of the undamped pendulum. Yes, the trajectory is stable but not asymptotically stable. Yes, and in this case we have just 0, so v dot is constant along the trajectories, and so the trajectories do not approach the origin. So the oscillations. Or sometimes if you can't decide, maybe you should change, try another function sometimes. Yes, this is if the function doesn't work, you must try another function. Paul, your turn. Yes. The next will be the chalk. So task number 2 will be, so the same function v, x squared plus y squared. It will work. Usually it works. X dot equals y plus xy squared, similar problem. Minus x plus x squared y. Let's try this.
What a girl.
It is positive definite, yes. X dot, yes.
Let me just say. This is definitely positive definite. So
Yes, it is. It it is positive definite. Yes. So if x or y is 0, then it is positive semi-definite. Yes, positive semi-definite. This function is not positive definite
which other
because it is 0 for x equals 0 and for y equals 0. Yes, I think.
This is positive definite because x is equal to 0, y is equal to 10. 0.
Because so it is positive.
Oh, yeah.
Why it is?
Can't we just set another point which is equals to 0? But
So sometimes x is 0, but y is not 0. But what shall we do? Okay. Now for positive semi-definite.
let's see.
It needs be. So it is not asymptotically stable. It is not stable. Yes, but neither. Yes, maybe we should. But maybe. I think -2. Okay. If we change this, then we will get what? Minus, and then it will be. And we get negative semi-definite and so stable. Maybe in changing this. Yes. Okay. So maybe there is some mistake. I don't know. Okay. Now task number 3. X dot is equal to minus y minus x times x squared plus y squared. And y dot is equal to x minus y times x squared plus y squared. Okay, Daniel, your turn. Let's try. So you will try to find the derivative of v. V is the same.
The thought that counts, right? If I try, I get a point, right?
Yes.
I don't get the answer.
Why?
Diplomatic. So, if I remember, we have the v, x, y. Same one, right?
So the same function, x squared plus y squared. Is it positive definite?
Is it?
Positive definite, Daniel.
It's positive definite.
Positive definite, yes. Positive definite, yes. Next, let's try v dot. This is the most difficult problem for you.
Yes.
V dot.
V dot is going to be equal to 2x dot
Yes.
plus 2y.
Yes.
Not as difficult. Now we do substitution.
Yes.
Yes.
From the system.
Yes, that is correct. It's going to be equal to 2x open bracket minus y minus x squared plus y squared plus 2y x minus y x squared might,
Mhm.
can I raise this?
Okay. Mhm. Yes.
Oh, I didn't see that one. All right. So, so, I would say simplify it,
Simplify, yes.
whatever it's called. Going to be minus 2y.
Next. You may leave it in the form 2x squared times x squared plus y squared. You needn't multiply it in 2x squared times x squared plus y squared.
Like this is fine, right?
Yes, yes, okay.
Plus 2y.
Yes, they're the same.
Multiply to them. Minus. What? Oh my God. Minus 2y squared. X squared plus y squared.
Yes.
Hooray.
And then how to simplify these?
There's a way.
Can you factor this?
So this should be factor.
So they have the common factor minus 2 times x squared y squared.
Yes. X squared plus y squared. And then it's just going to be this multiplied
Yes.
by x squared plus y squared.
Y squared, no, inside the bracket. Yes, Is it?
X squared plus y squared the whole.
Yes. Is it positive definite or negative definite or? What can you say about it? Is it positive or negative? If we substitute if we substitute points, some values for x and y, will it be positive value or negative value? So if we substitute 1 and 1,
It's going to be positive, of course.
it will be negative because it is multiplied by negative 2.
Negative.
Negative 2 is multiplied by by two positive numbers.
This will make it negative because this one.
Negative. It is always negative, of course, negative. And it is neither 0 except for the origin. So it is negative definite. And the system is asymptotically stable, yes, by Lyapunov's stability theorem. Asymptotically stable. So the answer is asymptotically stable.
And how do we check if it's asymptotically stable?
Okay, so if V is positive definite and V dot is negative definite, then it is asymptotically stable. If V is positive definite and V dot is negative semi-definite, then it is just stable, not necessarily asymptotically.
So if Vxy is positively definite and this one is negative definite, then this is
asymptotically stable, yes. And if it is positive and positive, but not necessarily positive definite, but some function which is at some point positive. Yes, and if V dot is positive definite, then it is unstable.
I understood. Okay.
Well, so this is the rule. Oh, okay, so that's all I think we can finish. Wow. So how much time? Так, вообще это должно было бы закончиться там без прям еще час, да? Мы. Ладно, все, мне просто больше nothing to say.